everyone, and welcome to today's crash course. This video is intended for secondary 4 students. So we're going to be talking about energy efficiency, but we're going to divide it into 2 parts because there's a lot to kind of dig through. So the first part, we're going to be talking about what energy is, the law of conservation of energy, and energy transfers and transformations. And then later in the second part, we'll tackle energy efficiency, its definition, the formulas, and a couple of examples for you to try out. So the first thing we need to do is talk about what energy is. And energy, by definition, is the ability to do work or cause change. And it is measured in joules. So when we take any type of system, when we take an appliance or we take an organism, any system requires an input of energy to do work. So for example, our cell phones. Our cell phones need to be charged. They need that input of electrical energy to do the job that they're supposed to do. If we look at aircrafts, they require an input of chemical energy through jet fuel. Fossil fuels are chemical energy. And then finally, we also have plants. Through photosynthesis, they need that energy from the sun, that radiant energy, in order to produce their own food. So in order to do that work, they need an input of energy. So any system, doesn't matter which, needs that input of energy. So here are the different forms of energy that you're required to know in secondary 4. The first being mechanical energy. It's energy of matter or electrons moving in an orderly way. So hydraulic energy, wind energy, sound energy, those are all examples of mechanical energy. Then we have thermal energy. And when we think of thermal, we think of heat. So it's energy of agitated particles in a substance. Then we have radiant energy, and that's energy carried by electromagnetic waves, light, X-rays, microwaves. And then we also have chemical energy. And chemical energy is where energy is stored in chemical bonds in atoms or molecules, like in fossil fuels or glucose. And then finally, nuclear energy, which is energy of particles through fusion or fission of atoms. So what happens to this energy when it enters a system? We always have to keep in mind the law of conservation of energy. And it goes like this. Energy cannot be created nor destroyed. It can only be transferred or transformed. So the total amount of energy is always the same in a closed system. We have to keep that in mind whenever we think about energy. So what is an energy transfer? Is it A, a transfer of one form of energy to another form of energy, or B, a transfer of one form of energy from one place to another? The answer is B, a transfer of one form of energy from one place to another. So energy transfer is the flow of a form of energy from one place to another. So if we take an example like the electrical energy that is transferred from the outlet to any device, our computer or our cell phone, that is a transfer of electrical energy. We also have an example like thermal energy. When we put a pot on a stove, that thermal energy is transferred from the stove to the pot and then from the bottom of the pot to the top of the pot. Now, energy within a system can also be transformed. And so energy transformation is the change of one form of energy to another. So once we have that electrical energy in our laptop, it is then transformed into radiant, thermal, and mechanical energy. Another example will be during photosynthesis. That radiant energy is turned into or transformed into chemical energy in the form of glucose. Which of the following objects transforms electrical energy into mechanical energy? Is it A, Christmas lights, B, a helicopter, C, a washing machine, or D, a solar panel? The answer is C, a washing machine. So let's take a look at the inputs and outputs for each system. So we have the Christmas lights, and the energy input will be electrical energy, and the output that we want from those lights is radiant energy. We want those lights to sparkle at Christmas time. A helicopter, well, the input is chemical energy through fossil fuels, right? It needs that fuel to actually perform its job. And the output is mechanical, thermal, and radiant energy that we get out of that helicopter. Now, a washing machine's input is electrical because it's plugged into a socket. It needs that electrical input in order to function. But remember that washing machines have a lot of moving parts. So we get mechanical, radiant, and thermal energy. And then finally, we have our solar panel, which will give us our radiant energy that is turned into electrical energy. So let's just summarize all the things that we talked about in this video. Remember, energy cannot be created nor destroyed. That's our law of conservation of energy. Energy can be transferred from one place to another, or it can be transformed from one form to another. And always remember that within any system, the amount of energy input is equal to the energy output. So now that we've done part 1, make sure to check out part 2 where we talk about energy efficiency.